Welcome guys to my YouTube channel. In today's video lesson, I'm going to be teaching you electric field in physics, okay? Now, this class is meant for the supplementary JAMB students as well as the forthcoming post-UME students. Please, I want you to pay attention to this particular topic. Remember I told you in my previous video, the one I did last week, that some students are here to see their result and they just reschedule them for another JAMB, and the JAMB is called the supplementary JAMB now in 2024. So in this video lesson, I'm going to do a summary for electric field in physics, both for the supplementary JAMB student and the post-UTME student. And I'm going to try as much as I can to summarize it so that you will be able to solve any questions in electric field in less than 20 or 25 minutes. Now let's quickly go into this video lesson. What is electric field? Electric field is a region of space around a charged body where the effect of electric force can be felt or can be experienced by another body. Okay, now the law that governs this electric field is called the Coulomb's law. So let's quickly go over to what we call Coulomb's law. Let's be fast with this. Coulomb's law. What does Coulomb's law talks about? Like I told you, I'm doing a summary in electric field. What does Coulomb's law talks about? Coulomb's law states that the force of attraction or the force of repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of their distance apart. Okay, you can pause it to recall the definition. Now, according to Coulomb's law, he said if I have two charged bodies, it could be positive and negative where there will be attraction, or it could be positive and positive or negative negative. That is to say, it could be like charges or unlike charges. Now let's consider the force of attraction between two unlike charges. Let's assume we have a proton which is positively charged and we have electron which is negative charged. Remember, there is a force of attraction between these two bodies because they have opposite word charges. Now, the distance between this one and this one is termed as word r. So arrow will represent our distance in the course of this electric field. Now, the charge here, let's call it Q1 and call the charge here Q2. So according to Coulomb's law, he said that the force of attraction between these two charged bodies is directly proportional to the product of their charges. You know, product means multiplication. So we are likely to multiply this together. So we have Q1 times what? Q2. And it is now inversely proportional to the square of their distance. You know, the distance between positive and negative is r. So the square of the distance is termed as arrow square. So what do? It means that it becomes inversely proportional to your word arrow square, which is your distance. That's what Coulomb's law talks about. So what do we do now? Remember that we have to remove the sign of proportionality and put our constant. So if I do that, I will have F equals to, so writing this sign, I'll put equals to, then I will have to introduce my constant. What is my constant? My constant is what? K. So we have K, Q1, Q2 over weighting arrow square. So this becomes the formula for the force of attraction or repulsion between two charged bodies in an electric field. Now let's do this. Remember, this guy K is called the constant. What does the K represent? Your K, which is called your constant, is equivalent to what value? Is the same with 1 over 4 pi, then permittivity. This guy is called permittivity. It's either called the permittivity of a medium or the permittivity of free space. Okay? Now, this same guy, or this K, is equals to 9 times 10 raised to the power of 9 Newton meter square per Coulomb weighting square. So please take note of this. It is quite very, very easy. So if our K is 1 over 4 pi, can I substitute this into this formula? Yes. It means that my force of attraction or repulsion will now be equals to 1 over 4 pi then permittivity. Remember I said this guy is called permittivity. It's either called permittivity of free space, as in a free space or in a vacuum, or permittivity of a medium, okay, like air and water. Now, if I have force equals to, this one is representing my K here, then what do I have left with? I'm left with what? I'm left with Q1, Q2 over weighting now and rho square. So if I combine them together, seeing that this guy, this one here, represents my K. If I combine them, and we have F is equals to K Q1, sorry, and we have F equals to Q1, Q2 over, that means if I use 1 to multiply this, I have the same thing. This multiplied to give me 4 pi permittivity rho square. So we either take this as our force of weighting and attraction, or the force of repulsion, or we'll take it this way. But take note of this. Remember what I told you. This one is the first charge. This is the second charge. Okay? Now, and I said that arrow represents our distance. Remember that this guy is called weighting. It's called permittivity. Permittivity. Please take note of that. And this permittivity is measured in farad per meter. That is the unit. It is measured in what? In farad per meter. Now, I want you to understand that this permittivity that we're talking about, it can be permittivity of free space. So we can say that in free space, your permittivity, which is this one, is equals to permittivity naught. So this is the symbol for the permittivity of charge in free space. That's in free space or vacuum. You know, vacuum also means an empty space. Then in a medium, what did I tell you is a medium? In a medium, like weighting, like air or water. In a medium like air or water, this permittivity now will turn automatically to become permittivity of the medium. This permittivity of the medium, this permittivity of free space. So take note of that. Again, we have what we call relative permittivity. Yes, there's what we call relative permittivity. The last one, 1, 2, then we also call relative permittivity. Relative what? Permittivity. What does it mean? First of all, the symbol is permittivity arrow. Your relative permittivity is the ratio of the permittivity of the medium to the permittivity of free space. Take note of that. Is the ratio of the permittivity of the medium to the permittivity of weighting free space. So we mean that our permittivity of relative permittivity is permittivity of the medium over the permittivity of free space. Remember, for free space, we have weighting E naught. Now what I'm going to do, I'm going to take just one question on this, then we'll go over to the next step. Let's take just one question. Now let's take this question. Question number 1. 2 identical charges situated 20 centimeters apart, okay, in a vacuum, repels each other with a force of what? 1.018 Newton. Are we together? Calculate the value of each charges. Now we are looking for charges, not force. But remember, for 2 charges, whether they are what? Similar or not. Now remember that the force of attraction is equals to what? K Q1 Q2 over rho square. Or you can use, instead of this K, you can do 1 over 4 pi permittivity, then you have Q1 Q2 over rho square. Seeing that your 1 over 4 pi permittivity is the same value for K. Are we together? Now, watch this carefully. Remember, we are looking for the charges. They said that the 2 charges are what? Identical. So there will not be need for us to label it as Q1 and what? Q2. Seeing that the charges are identical. So let's remove this. Remove this. By the time we combine these 2 charges together, we are going to get weighting Q squared. Yes, that's what we have. We have Q times Q because the charges are what? Identical. Again, remember that 1 over 4 pi permittivity. This guy, 1 over 4 pi, do you know is the same thing as 4 pi permittivity all raised to the power of -1. Remember the laws of what? Indices. Now let's quickly do this. If we are working with this, it means that our force will be equals to, listen, this one is 1 over 4 pi. So we have 4 pi permittivity of free space, then raised to the power of minus 1. What do we have as our charges? Now, we have Q squared over weighting arrow squared. So let's fill in our values. Remember the force is what? 1.0 weighting Newton. So put it here, 1.0 equals to, what is this one? They gave us, yeah. If is the value for K, you have 9 times 10 raised to the power of 9 times Q squared. We are looking for the charges over arrow squared. What's the distance? The distance is what? 20 centimeter. Okay, now watch this. If our distance is equals to 20 centimeter, remember that we don't solve in centimeter, we solve in meter. So we have to convert from centimeter to meter by dividing with weighting 100. So when you divide with 100, you are going to get 0.2 meter. So our distance is not 20 centimeter, it is 0.2 meter because we have divided the centimeter by what? 100. So we are going to get 0.2 weighting square. Wow, that's interesting. So what do we do now? Very easy. You can use this to, you can cross multiply it. You can take it this way like this and shift this one 0.2 what square. So we can cross multiply now. So you have 1.0 times what? 0.2 square equals to, you have these two left. You have 9 times 10 raised to the power of 9. Q what now? Q square. Now what is 0.2 square? That's 2 over 10, 2 over 10. You have 4 over 100 and you have 0.04. So that means this one is 1 times 0.04 equals to 9 times 10 to the power of 9 Q squared. If you multiply these two, you have 0.04 equals to 9 times 10 to the power of 9 Q squared. So divide both sides by 9 times 10 to the power of 9. Do the same here, 9 times 10 to the power of 9. So this one cancel this. You have Q squared equals to, let's do this. Listen, be careful. We are going to do 0.04 over 9. Remember the calculator you are using does not have exponential. So we have 0.04 divided by 9. You have 0.00444. We have 0.00444. If you divide this. Now, if this 10 raised to the power of 9 goes up, it becomes 10 raised to the power of minus 9. Now, what do we do? Listen. How many zeros do we have here? Or let us take our point to put it in a standard form. We have, watch this, you have 1, 2, 3. So that means you have moved 3 times before you get to a non-zero digit. So if you move 3 times, it becomes minus 3. So you have minus 9 minus 3. That will give us what? Minus 12. So that we have Q squared is equals to now 4.44 times 10 raised to the power minus 12. Since we are looking for Q, not Q squared, we take the square root of both sides. So we take the square root of this one, take the square root of this one. Square cancels. So what do you have now? Now, what is the square root of 4.44? The square, if you are writing an exam where you don't have square root in your calculator, you can get it. Knowing that the square root of 4 is 2. So we look for a number close to 2 is this. So we can say that the square root of 4.44 is 2.1. Yeah, 2.1. So if you have 2.1, square root of 10 to the power minus 12 is 10 to the power of what? Minus 6 weighting a column. This is the answer. But when you come back to the option, you see microcolumn. It means that you have to divide your answer with 10 raised to the power of minus 6. So if you do that, you divide this guy by 10 raised to the power of minus 6. You have it this way. Watch this. Q becomes 2.1 times 10 raised to the power minus 6 all over 10 raised to the power of minus 6. Why am I dividing with 10 raised to the power minus 6? To reverse it back to microcolumn. So this one optimize this. So you have Q is equals to 2.1 microcoulomb. Wow. So the answer is what now? A. Okay. Now let's quickly go to electric field intensity. Electric field intensity, that's phase number 2 in electric field. What is electric field intensity? Take your book and your pen and write it down. Electric field intensity has a symbol E. as you can see. It is either called electric field intensity or it's called electric field strength, or you call it electric field. That is the electric field itself, okay? Now, the electric field intensity is the force per unit charge. That means it is force over charge on a charged body. So that is to say, from the definition, you can say that electric field intensity is equals to weighting a force over what? Over charge. It is the force per unit charge. Now, if this is the formula, it means that we can determine the unit. What is the unit? Force is measured in Newton. Charge is measured in Coulomb. So you have Newton per Coulomb. Is that clear? Now, again, remember that the force there is called electric force. And you know electric force has its own formula, abi? The electric force is equals to KQ1 Q2 over weighting R square. Now, electric force formula be this. So if I call this guy now equation 1 and I call this guy now equation 2, I can decide to put this one into this. So I can say put 2 into weighting into 1. Oh yeah, let's do that quickly. If I take force and put it here, it means that E will be equals to what? Watch this. Instead of having force, we have K Q1 Q2 over R squared. So we are having force over charge, of which you can say force times 1 over charge. If you have A over B, it's the same thing as A times 1 over weighting B. You understand? So this is your force, while this one is your charge. So if we write our force here, we can now say times 1 over charge. Force over charge is the same thing as force times 1 over charge. Now this one can cancel one of the charge, so that electric field itself will now become K. You know, this is Q1, Q2. The numbering does not matter. It's just to tell you that there are 2 charges there. So now that you have cancelled one, there's no need of writing Q2. Just write ordinary word Q over R squared. So how many formula have I given you for electric field intensity now? 2. I've given you this one and this one also. So this is the other formula for electric field weighting intensity. But the unit still remains the same. It is Newton per weighting Coulomb. Now watch this carefully, please. Watch this carefully, please. Remember, recall that our K is equals to what? Our K is equals to 1 over 4 pi permittivity of either free space or what? Or medium. Okay? Now, so I can take this and put here, so that my electric field intensity will become what? Watch this. K is 1 over 4 pi permittivity. Are we together? Good. Permittivity times what? Times Q over R squared. So you have Q over R squared. Are you seeing it now? These are our K. So you can combine together to give you E equals to Q over, multiply this, you have 4 pi permittivity weighting R squared. Wow, that's interesting. So that is to say, our electric field intensity can be force over charge. It can be what? Electric intensity can be equals to what? It can be equals to KQ over R squared, or finally, it can be equals to Q over 4 pi permittivity weighting R squared. Wow, that's interesting. So this is for your word, electric field weighting intensity. Is that clear? Good. Now let us go to electric field potential. Now, electric potential, that's phase number 3 in electric field. Electric potential is the work done in bringing a unit charge from infinity to that point against the electric force of the field. Okay? It is the work done in bringing a unit charge from infinity to that point against the electric force of the field. Now, the definition gave us that electric potential, the symbol is V. Remember, electric field intensity is E. Okay? Electric potential is what? V. So you have V equals to the work done in taking a unit charge. You see how now? Good. So what becomes the unit? Wow, very cheap. Work done is measured in joule. Charge is measured in coulomb, so that we have joule per coulomb. Is that clear? Now, remember that work done is equals to weighting force times distance. Abi? Good. So don't forget in field, our distance is R. So that means our work done is F times weighting R. Now, if work done is force times distance, if we call this guy equation 2 and call this guy equation 1, I can ask you to put 2 into waiting into 1. Oh yeah, let's do that quickly. So V will give us, instead of having work over charge, we are now having waiting. F arrow over what now? Over Q. F arrow over Q. Okay, if you have F arrow over Q, remember that this becomes equation what now? Equation 3. Okay, now if this is equation 3, we can remember that this is your force. Okay, what is your force? It's electric force. Okay, so we can say, but our force is what? Is KQ1 Q2 over what? Arrow squared. Are you seeing it now? So this one now can be put into this force so that our V will give us, instead of force, we have KQ1 Q2 over arrow squared. That's this force. Then we are left with arrow over Q. So we have times arrow over Q. First of all, Q cancel Q. Are you seeing it now? Yes. Now if Q cancel Q, this one can cancel this one. So you have just one arrow here. So we are left with K Q2 over arrow. You see now, no need of writing Q2. Okay, since you have only one charge. So our electric potential has given us another formula as what? KQ over waiting over R. Are you seeing it now? Now, but remember that, but what? Your K is equals to what? 1 over 4 pi, 1 over 4 pi permittivity of free space or medium. So we can put free space, okay? If we are assuming that it's what? Free space, okay? Now, put this guy now into this, so you have V equals to, you know this is the actual formula, but you know what K is, because sometimes they can give you an expression in exam. So which of these gives the correct expression for electric potential? That's the essence of having all of these formula. Do you understand? Good. So you have V equals to, this one will give us what? Instead of K, you have 1 over 4 pi permittivity of free space times Q over waiting R. That will finally give us Q over 4 pi permittivity of free space R. So in conclusion, we can say that V is the work done in taking a unit charge. Abina, good. We can still say that V is equals to K, KQ over R. Then finally, V is equals to Q over 4 pi permittivity, then waiting R. All of these are the formula for electric waiting potential. Now, I'm going to show you the relationship between this electric potential and electric field intensity. Because if you look at them, see that they are similar, but you have to be careful. Remember that for electric field intensity, E is equals to force over charge. Remember, the second time we got KQ over arrow squared. The third time we got Q over 4 pi permittivity of free space arrow squared. You see them now. So the difference between them is that this guy, electric field intensity carries square in its radius, but electric potential do not carry square. Are you seeing now? So here you have arrow, but here you have arrow square. Here you have arrow, here you have arrow square. That's one distinguish them. They have one charges. Are you seeing it now? Good. So be careful. Again, if I want, there's a formula that relates electric field intensity and what now? Electric what? Potential. So let's do that quickly. Relationship between electric field intensity and electric potential. Now let us cut it short without wasting our time. The relationship between them is that electric field intensity is equals to electric potential, which can also be called potential difference. So take note of that. Electric potential can also be called potential difference. So potential difference over distance. So that's it. Or you can cross multiply to say electric potential is your word, your electric field intensity times your word, distance. Are you seeing it now? In this place now, what becomes the unit for electric field intensity? What becomes the unit? Should be this kind of potential difference and it's measured in volt. Abi? Good. So one is distance, Abi? So you have volts per meter. This is another unit for waiting for electric field intensity. You see it now, right? Good. What about this one? What's the other unit? Remember that this guy can be Newton per coulomb. That's electric intensity. This one is what? Meter. So it is Newton meter per coulomb in combination. Newton meter per coulomb. You see now? Good. So this formula is very, very important. Crammer. Because sometimes they'll give you question related to electric intensity. They will not give you what you need. They will give you potential difference and distance. You just solve and you get your answer. Is that clear? Yeah. So I have just 2 questions for you because this is the end of electric field itself. This is what it encompasses. Now, I'm going to take 2 questions, just 2. Then in my next video lesson, I will show you electric field patterns, how to draw your electric field patterns, so that if they give you a different diagram for electric field pattern, you'll be able to identify it correctly. Is that clear? So now let's take just 2 questions relating to electric field intensity and electric potential. Let's take question number 2. Question number 2 says what? Calculate the force acting on an electron of charge. This is the charge of the electron. Let's do that quickly. Question number 2. Charge is 1.6 times 10 raised to power minus 19 coulomb. Okay? Placed in an electric field of intensity. The electric field intensity is 10 raised to the power of 8 volts per meter. Now, they said, okay, I guess the question is not complete. Okay, calculate the force. Yeah, this is the force. We're looking for the force, okay? So calculate for the weighting and force. Calculate the force acting on an electron of charge. This is the charge of the electron placed in an electric field of intensity. Okay, so they gave us the charge of the electron. They gave us the electric field intensity. We are looking for weighting and force. Remember that electric field intensity, that's solution to number 2 now, is the force over weighting and over charge. If you make force your formula, you just simply cross multiply. Are you seeing it now? So that your force can now be equals to electric field intensity times weighting and times charge. So if I'm looking for force, force will be equals to E times weighting and times Q. So it is very, very cheap. Are you seeing it now? So what do we simply do? Put your parameters. Charge is electric intensity is what? 10 raised to the power of 8. What is your charge? Charge is 1.6 times 10 raised to the power of what? 19. Are you seeing it now? Good. So this 1.6 still remains times 10 raised to the power of what? This is 8 minus 19. Okay? Or remember that if you are combining 2 index numbers that are combined together with the symbol multiplication, you pick one of the base, then you plus the power. So you have 8 plus minus 19. It's the same thing. So that minus plus will give us weighting and minus. I see now. So like we're having 19 minus 8. This will give us 11. So 8 minus 19 will give us minus 11. Are we together? Yes. Okay, so you have 1.6 times 10 raised to the power minus 11 watts now. Newton. So let's quickly check on the option. Our answer is weighting at A. So it's very easy. Let's take question number 3. Question number 3. Question number 3 seems to be a little bit tricky. Question 3 seems to be a little bit tricky, so you have to be careful. A point charge of magnitude. They gave us the charge. Number 3. Charge is equals to 2.5 microcoulomb. This is the symbol for microcoulomb. If you are given a microcoulomb, you must convert to coulomb by multiplying with weighting at 10 raised to the power of minus 6. So if I times this guy with 10 raised to the power of minus 6, I will come get Q equals 2.5 times 10 raised to the power minus weighting at 6 coulomb. So it's no longer a microcoulomb, it's now a weighting coulomb because I have multiplied with 10 raised to the power minus 6. If you want to convert from coulomb to microcoulomb, you will now divide with 10 raised to the power minus 6 like we did in our previous question. Is that clear? Good. Now, okay, it's moved through a what? A distance of weighting 0.4 meter. Remember, our distance is not D, it's arrow in field. So we have our arrow equals to 0.4 weighting a meter. You see I'm now? Good. So that this is our distance arrow, okay? Now, what did they say again? They now said that apart against a uniform electric field of intensity. Wow. Electric field intensity is equals to what? 15 volt per meter. Remember I told you that electric field intensity is Newton per coulomb or volt per meter. Okay, good. So that's electric intensity. Calculate the work done on the chart. Calculate weighting and the work done. This question looks like a combination of electric potential, which is V, that has to do with work done, and electric intensity itself. Okay, so what do we do? Very simple. Let's bring out both of them together. Okay, seeing that we have electric field intensity is equals to force over weighting and over charge. Are you seeing now? Electric field intensity is force over charge. What are we looking for? We're looking for the work done. Okay, we're looking for what now? Work done. Remember that work done is equals to force times weighting and distance. But if work done is equals to force times distance, do we have force in the question? No. Do we have distance? Yes. So we have this distance, but we don't have this force. But we can get this force. This force. You know, we are looking for work done. We can get this force from here because electric field intensity is force over charge. So cross multiply like this here. Force will come give us weighting now. E times weighting now times Q. You understand now? So if this one now is now our force, our work done W, which was force times distance, force is now EQ, so we now have EQ, which is the force times distance, which is weighting now R. So we can solve for our work done. E is what? Did they give us E? Yes. What is E? E is weighting is 15. See, 15 times Q. What's the charge there? See, charge. We have converted to weighting 2.5 times 10 raised to the power of what? Minus 6. Did they give us distance? Yes. Our distance is weighting at 0.4. So we have 0.4. Wow. So we have to multiply 15 times 2.5 times 0.4. Leave this 10 raised to the power 6 first. Let's do that quickly. 15 times 2.5 times 0.4. Wow. 15 times 2.5 times 0.4 still give us 15. So we have 15 times 10 raised to the power of minus 6. You see am now? Good. There's no point here. It means that the point is here. If I have a number like 88, there's no point. It means that the point is here. So if the point is here, I have to move the point here like this. If you move backward, you have 1.5 times 10. Since you move only once, you add 1 to the power. So if I have minus 6 plus 1 give us minus 5. So you have minus 5. Remember, you're looking for work done. Minus 5 weighting at joules. This is the weighting at work done. So let's quickly look for our answer. Wow. Okay, we have 1.5. I guess this is minus 5. Yeah. So our answer is what now? B. 1.5 times 10 to the power of weighting now minus 5. Because 15 times 2.5 times 0.5 will give us 15. So we are very, very accurate and we are what? Correct. Now we have come to the end of today's video lesson. If today is your first time for coming across my YouTube channel, please do well to subscribe to the channel. If you have a friend preparing for post-UTME or preparing for forthcoming JAMB examination, help us to share this video, and please do not forget to like our video. If you have any question to ask as within topics involving electric field, please do well to send your question to us on the comment section. I will reply you. It's a promise. Thank you very much. I will see you in my next video lesson.